Hello everyone, welcome to the channel. This is our 100 LeetCode interview question series where we will solve the most important DSA problems pattern by pattern. In today's video, we will solve LeetCode 26, remove duplicates from sorted array. This is an easy problem from the arrays pattern and is a great problem for learning in-place array manipulation. In this video, we will cover understanding the problem statement, brute force approach, optimal algorithm, Python, Java, C++ solution. And finally, I will give you 3 similar LeetCode problems as practice. So let's get started. Let's first understand the problem statement. We are given a sorted integer array called nums. Since the array is already sorted, duplicate elements will always appear next to each other. Our task is to remove these duplicate elements in place so that each unique element appears only once. There are two very important conditions in this problem. The first condition is that we cannot create a new array. We have to modify the original array itself. The second condition is that the relative order of the unique elements should remain the same. Now notice something important. The problem is not asking us to return the modified array. Instead, we have to return the number of unique elements represented by k. After our algorithm finishes, the first k positions of the array should contain all the unique elements in their original order. The remaining positions are not important because LeetCode only checks the first k elements. Let's understand this with the first example. The input array is 1, 1, 2. Here the unique elements are 1 and 2. Therefore, the number of unique elements is 2. After modifying the array, the first two positions should contain 1 and 2. Now let's look at another example. This is the input array which is given. The unique elements are 0, 1, 2, 3 and 4. So the answer is 5. The first 5 positions of the array should contain these unique values. So before we think about the solution, let's summarize the problem. The array is already sorted. We have to modify it in place. We cannot use extra space. We need to return the count of unique elements. Now that we clearly understand the problem, let's move on to the algorithm and see how we can solve it efficiently. Let's first think about the brute force solution. Whenever we hear the word remove duplicates, the first idea that comes to mind is to create another array. We traverse the original array from left to right. Whenever we encounter a new unique element, we simply add it to the new array. If we find a duplicate element, we ignore it. After traversing the entire array, the new array will contain only unique elements. Let's understand this using an example. Initially, our new array is empty. We add 0. The next 0 is a duplicate, so we skip it. Then we encounter 1, which is unique, so we add it. We continue this process until the end. Finally, our new array becomes 0, 1, 2, 3, 4. Let's analyze the complexity. We traverse the array only once, so the time complexity is big of n. However, we are creating another array to store the unique elements. Therefore, the space complexity is big of n. Now comes the important question. Is this solution acceptable? Unfortunately, no. The problem clearly states that we have to modify the array in place using constant extra space. Since we are using an additional array, this solution doesn't satisfy with problem requirements. So let's think of a better approach. The first thing we should notice is that the array is already sorted. This is a very important observation. Because the array is sorted, all duplicate elements are placed next to each other. This means we don't actually need another array. We can simply override the duplicate values inside the same array. To achieve this, we will use two pointers. The first pointer is the read pointer. Its job is to scan every element in the array. The second pointer is the write pointer. Its job is to point to the position where the next unique element should be placed. Initially, both pointers start at index 1. The first element is always unique, so we don't need to process it. Now we start traversing the array using the read pointer. Every time we find a new unique element, we copy it to the right pointer position and move the right pointer one step forward. If the current element is a duplicate, we simply skip it. We repeat this until we reach the end of the array. Finally, the value of the right pointer tells us how many unique elements are present. Let's dry run the algorithm. Initially, both read and write pointers are at index 1. The read pointer checks the second element. Since it's the same as the previous element, it's a duplicate. We skip it. Next, the read pointer reaches 1. This is different from the previous unique value, so we keep it to the right pointer position and increment the right pointer. We continue following the same process. Whenever we encounter a duplicate, we skip it. Whenever we find a new unique element, we override the next right pointer position and move the right pointer. At the end of the traversal, the first part of the array contains all the unique elements and the right pointer gives us the answer. Let's analyze the complexity once again. We traverse the array only once, so the time complexity is big of n. Since we are modifying the original array without creating another one, the space complexity is big of n. This satisfies all the constraints of the problem. Now that we completely understand the algorithm and why it works, writing the code becomes straightforward. Now that we have a clear understanding of the algorithm, let's implement it. I will first show the solution in Python, followed by Java, and finally C++. Since the algorithm is exactly the same in all three languages, we will focus mainly on the implementation. Let's start with Python. First we handle the edge case. If the array contains 0 or 1 element, we simply return its length. Next, we initialize our right pointer j to 1. We will use another pointer I to traverse the array starting from index 1. For every element, we compare nums of I with the previous unique element, which is nums of j minus 1. If they are different, we found a new unique element, so we copy nums of I to nums of j and increment j. If they are equal, it's a duplicate, so we simply continue. After the loop finishes, j represents the number of unique elements, so we return j. The Java solution follows the exact same logic. We initialize the right pointer j to 1. The for loop uses I to traverse the array. Whenever nums of I is different from nums of j minus 1, we copy the element to the right position and increment j. Otherwise, we skip the duplicate. Finally, we return j. The C++ implementation is also identical. The only difference is the syntax. We maintain two pointers, I for reading every element, j for writing the next unique element. Every time we encounter a new unique value, we override the current right position and move the right pointer forward. Once we have processed the entire array, we return j, which is the total number of unique elements. As you can see, the algorithm remains exactly the same across Python, Java and C++. The only thing that changes is the programming language syntax. If you understand the algorithm first, implementing it in any language becomes much easier. Before you leave, I have a small assignment for you. Don't just watch this video. Practice is what improves your problem solving skills. Solve these three related LeetCode problems on your own. LeetCode 27. Remove element. Remove duplicates from sorted array 2. LeetCode 80 and LeetCode 88. Merge sorted array. Try solving them without looking at the solution first. If you get stuck, spend some time thinking before checking the editorial. If you found this video helpful, please consider liking the video and subscribing to the channel. I am creating a unread LeetCode interview question series organized pattern by pattern to help you prepare for coding interviews. I will see you in the next video. Until then, happy coding and